Hey everybody! In our lesson today we are going to talk about the basic concepts of kinematics, introduce the basic terms that we are going to work with in our lessons. Let's get started. Our task is to familiarize ourselves with the basic terms that we will work with in the future. And now we will introduce basic concepts that we will need to solve problems and explain many mechanical phenomena. Let's get started. First of all, we have to deal with what kinematics studies. Kinematics studies motion. The motions of any bodies, be they animate objects or inanimate objects. If we talk about motion, then we must try to describe it in terms of basic quantities. What are these quantities? The first quantity we will introduce is called trajectory. Why do we need to introduce such a concept? Depending on the trajectory, there are different types of motion. A body can move along a straight line, or it can move along a curve. From this, we divide motion into two basic types. These are rectilinear motion and curvilinear motion. Let's draw examples of trajectory. Suppose a body was moving from point A to point B. The trajectory of this motion is a straight line. In this case, we call such motion rectilinear motion. If, on the other hand, from point A to point B, along a curved line, this motion is called curvilinear. In order to further describe this motion, we must introduce an additional concept called the path and the displacement. Let's use the figure to show an approximate trajectory of a body. Let's say the body was moving along some curved line from point A to point B. What is a path? A path is the length of a given trajectory. So if we walk with some instrument along a given line and measure its length, we get the path traveled by the body. We will denote hereafter the path by the letter L. In this case, we can measure it with different devices, and naturally, like any physical quantity, the path has a unit of measurement. In our system of units, we'll measure the path in meters. This quantity is scalar, i.e., it has no direction. Regardless of where the body is moving, the path will always be a strictly positive number. This must be remembered for solving future problems. What do we get if we connect the starting point of the trajectory and the end point of the trajectory? Let's do it. So, we get with you some vector, which will show from where and where the given body moved. In this case, we call this quantity the displacement of the body. It's denoted by the letter S. And we put a vector sign to show that this quantity has its own direction. The direction of displacement will always have from the initial point of the trajectory to the final point. There are different ways to determine the displacement of a body. It will depend on the specific problem. In all likelihood, we can use some geometric relations. We will see how this works in practice using examples. But the displacement, as well as the path, will naturally be measured in meters because it is also some distance. But the only thing now is the directed segment, the length of which we will also measure in meters. These are the basic quantities with the help of which we will solve our tasks in the future. Let's go over again what L is. Now L is a path, and S is displacement. So we have our three concepts ready to go: trajectory, path, and displacement. And now we will be ready to describe motion in future problems. I'll see you in the next lessons.